Brock. Hello, everybody. Brock. There's no here. Welcome back. Today we're going to check out the review of geometry. Brock. And of course, if we were here for the construction unit, I would teach you how to make all these cool things. I'll show you these in a little at the end of the video. But let's check out the review answers, and I'll give you a little bit of extra review because tomorrow is the test. Brock. Friday is the test on geometry. Make sure you log in. Brock. Okay, so this was the review we had with the 9 questions. Here's the answers. Okay, the first one, draw 3 congruent circles. Congruent means the same. So when you hear the word congruent, this means equals. We kind of put a little squiggly, means it's kind of the same. Let's switch over. So you're supposed to make a circle, and all the circles had to be tangent. So tangent is barely touching. So here it is. Here's the 3 circles barely tangent. So some of you got confused about tangent, not crossing, not separate, but just touching. In class, I got lots and lots of these posters with all these vocabulary. And so we missed out. I've got maybe like 200 vocabulary words, how you could describe all these things. So there's 3 circles that are all tangent. So tangent means just barely touching. And then it says to connect the tangent points. So here's a tangent point, here's a tangent point, and a tangent point. If you connected them, you get a little equilateral triangle. All these are the same. You get an equilateral, that means equal sides triangle. And here's how you can be lazy to write triangle, equilateral triangle. Okay, number 2. Let's make a point, draw 3 centimeters up. So here's straight up, there's 3 centimeters, stop. Call it point B. So with stop, I like to make my points big. Draw 4 centimeters to the left. Uh-oh, I've run out of room on my paper. We'll start that over again. Okay, so we'll do 3 up from A, stop, call that point B. Now draw 4 centimeters to the left. We'll go straight to the left, stop, call it C, connect A to C. There you go. How long is AC? This was 3, this is 4. And this is 5. This is one of the most famous triangles called a 3, 4, 5. If you have a triangle with a perfect corner, and this side's 3 and this side's 4, this side will always be 5. The Egyptians knew this and used this knowledge to be able to construct perfect right triangles. You can do an entire chapter on this. It's called the Pythagorean theorem, but that's a whole other unit. But this was 5. Okay, next question, number 3. Okay, wants you to make an obtuse isosceles triangle. Okay, obtuse isosceles triangle. Mark one of the matching base angles 10 degrees. What size are the other angles? So obtuse means make an angle bigger than 90. So I made this really, really big angle. Make 2 sides of the same, so these measure the same length. I mark them. Draw on your 3rd side to make it a triangle. It says mark one of the base angles 10 degrees. So this little guy's 10 degrees. I'm not going to really do it with a protractor. If somebody just says it is, we'll assume it. And so make the other one 10 degrees. So this is one thing we notice about isosceles triangles. If these sides are the same, we have a tie. Remember, the longest side has the biggest angle. There's the big angle, big side. These are a tie, so their opposites are a tie. But the question is, what's this angle here? Where every triangle is 180 degrees. So I've got 10 plus 10 already. That's 20. 180 minus 20 leaves me with 160 degrees. This is a 160 degree angle. Even if it doesn't look like so on here, if I wrote 10 and 10, that's 160 because they have to add to 180. Next question, number 4. And here's the questions again, just in case you wanted to look at them. What shadows can a square make? What shadows can a cube make? What's interesting, a shadow can make any quadrilateral shape, pretty much anything with 4 sides, as long as it's got 4 sides. So it can make all types of 4-sided shapes, but it doesn't have to be a rectangle. It could actually be kind of crooked. Well, that's got 5 now, doesn't it? Okay, but you could get something like that. What about a cube? Believe it or not, it's hard to do here, but a cube, you could get a hexagon. I could draw on the screen for a moment. It's possible you could get a cube, and I can't do it here, but you could get a hexagon shape, kind of like that, the hexagon. Because imagine you looked at the cube three-dimensionally. I can't draw a cube on the screen. Draw a little better. Draw one gigantic. See, there's a cube, but look at the outline of it, this outer edge. If you got the light just right, you could actually get a hexagon. Didn't expect that. Okay, number 5. It says, make a scalene triangle. Mark S the smallest angle, mark T the biggest angle, mark the medium angle M. Which side is the biggest? Which is the smallest angle? Well, this is the smallest side, so it must be opposite, not touching, opposite the smallest side. This angle is the smallest. It's only open a little bit, so this has a short side. So we'll call this S. And then T is the biggest angle. Well, this looks like the longest side, so it must be opposite the biggest angle. Not touching, but opposite. So we'll call this angle T for biggest. Oh, wait, not B. T. Okay, it says T. And then the medium angle must be left over. This one must be in between. We'll call him M. And which side is the biggest? Well, that looks like side SM is the biggest. Sometimes people use like little letter t just to go opposite. You use the opposite letter in lowercase. Okay, here's some more questions. Here's number 6. Draw an upside down equilateral triangle. If we had compasses, I'd tell you how to make it perfect. Equilateral triangle with the base horizontal. Now draw a semicircle on top of it. Semicircle is half of a circle. Semi means half. Half circle. So this means half. Draw a semicircle on top of it using the top side of the triangle as a diameter. Now spin the solid. If you were to spin this like around and around and around and around, what would it look like? If it spun it really fast, it would look like an ice cream cone. So if you took a triangle and spun it, it actually turns into a cone shape. Matt, look at, you just trace the edges on the paper. Isn't that a triangle? Isn't the edges a triangle? But when you turn it 3D, make it a solid, yes, it's an ice cream cone. And number 7, we're wondering, what is this side right here? Well, the trick was, the easiest way is just add the numbers together and subtract the numbers. The longest this side could be would be 5 plus 9, 14. In other words, if you stretch it out 9 this way and bent this one out like this piece over here, the longest it could be is 14. But actually, it can't be exactly 14. It has to be just a little less than 14. Otherwise, it'd be totally flat. The smallest it could be, subtract the numbers. 9 minus 5. 9 minus 5 is 4. So if we got these really close together, 4, but wait, 5 and 4, how could it bend upward if it's equal? It has to be just a little bit greater than 4. So we like to say the answer is between 4 is less than x is less than 14. So add them and subtract them. But don't use an equals. It has to be like 4.1 or 13.9. So this is your range of answers, the possible outcomes. Next question, number 8. Draw a circle. Put a point inside of it, a point on it, and a point outside of it. Some people don't get that. Think if you were playing a game like in elementary school and they said, everybody get in a circle. Now somebody stand inside the circle. You'd be inside the circle. Okay? So you would be like right there, inside the circle. If I said to be on the circle, you'd be like on the circle, like right there. And if somebody said to stand outside the circle, you'd be like over here. So just make sure you understand inside, outside, or on. And the last one. All right, and here's number 9. It says, draw this. I drew it right here. With point A, draw a circle to the right of it. Now draw a tangent line. Again, tangent line throws a few people off. Tangent means barely touching. So draw a tangent line from the bottom of the circle to point A. So here's point A. So tangent, don't go through it. Not the top, to the bottom. Whoops, I missed. Get to just There you go, just touching the bottom the best you can. So there you are. You can go past it, but we'll just go from the bottom to right there. Draw a face in the circle. Okay, I can draw a face. It's hard to draw on this computer screen. And it's like I say, it doesn't draw very well. There we go. Describe your drawing. It's you losing your head. You can detach your head. So there you go. Okay, so don't forget to make sure you get credit. Read the rest of the assignment.